Look up at the night sky, what do you see? Twinkling stars scattered across the darkness. These tiny points of light are actually giant balls of burning gas. They are incredibly far away, but their light still reaches us, inspiring wonder and curiosity. Stars are not just beautiful, they are powerful forces of nature. They are the building blocks of galaxies, and they play a crucial role in the universe. Let's explore the fascinating life cycle of a star from birth to death. Stars are born in giant clouds of gas and dust called nebulae. These nebulae are like cosmic kitchens filled with the ingredients needed to create a star. Gravity is the master chef. It pulls the gas and dust together, squeezing it tighter and tighter. As the cloud collapses, it heats up. Eventually, the temperature at the center becomes so intense that nuclear fusion begins. Hydrogen atoms fuse together to form helium, releasing a tremendous amount of energy. A star is born. Once a star ignites, it enters a long, stable period called the main sequence. Our Sun is currently in its main sequence. During this phase, a star fuses hydrogen into helium in its core, generating light and heat. The color of a star depends on its temperature. Hotter stars appear blue or white, while cooler stars appear red. The Sun, a medium-sized star, is yellow. The main sequence is like the adulthood of a star. It's the longest and most stable part of its life. After billions of years, a star begins to run out of hydrogen fuel in its core. The core contracts and heats up, causing the outer layers of the star to expand and cool. The star swells up to an enormous size, becoming a red giant. Red giants are huge and bright. If our Sun were to become a red giant, it would engulf Mercury, Venus, and even Earth. Section 5. When small stars fade, white dwarfs. The fate of a red giant depends on its mass. Smaller stars, like our Sun, eventually shed their outer layers into space. This creates a beautiful expanding shell of gas called a planetary nebula. The core of the star remains behind as a small, dense object called a white dwarf. White dwarfs are about the size of Earth but incredibly dense. A teaspoon of white dwarf material would weigh as much as an elephant. Section 6. The spectacular demise of giant supernovae. Massive stars much larger than our Sun have a more dramatic end. They continue to fuse heavier elements in their cores, creating layers like an onion. Eventually, the core collapses under its own gravity, triggering a catastrophic explosion called a supernova. Supernovae are some of the most energetic events in the universe. They can outshine an entire galaxy for a brief period. Section 7. Stellar remnants, neutron stars, and black holes. After a supernova, the core of the massive star can become either a neutron star or a black hole. Neutron stars are incredibly dense objects made up mostly of neutrons. They are only a few miles across but have more mass than our Sun. Black holes are even stranger. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. Section 8. The circle of stellar life. The death of a star is not the end. The material ejected during a supernova, or the formation of a planetary nebula, enriches the surrounding interstellar medium. This material contains heavy elements that were forged in the star's core. These elements become the building blocks for new stars and planets. In a sense, we are all made of stardust. Section 9. Our place among the stars. Stars are more than just distant objects in the night sky. They are fascinating objects that undergo an incredible life cycle. From their birth in nebulae to their dramatic deaths, stars play a vital role in the universe. They create the elements that make up our world and provide the energy that sustains life. The next time you look up at the stars, remember the amazing journey they have taken and their importance in the grand scheme of the cosmos.